We are going to further our discussion about triangles being congruent. In our previous lessons or lesson, you've learned that to prove that two triangles are congruent, you must show that all of their corresponding parts are congruent. So in two triangles, all three corresponding angles to each other would have to be congruent, while all the segments that correspond to each other would need to be congruent too. If we prove that all of those six parts are congruent to each other, then obviously we have to have congruent shapes. Well, the question then is there a way to show that we have congruent triangles without necessarily getting through every single part? So today we're going to explore something with an activity that will hopefully shed some light on this possibility. For this activity, if you were to follow this along at home and you wanted to try this, you're going to need three lengths, three pencils or pens or any type of writing implements. Need something to write with, like I have here. And then you're going to need a straight edge, as well as a Sharpie marker eventually to make some lines a little bit bolder. So what we're going to do here is we're going to take these three pencils. I'm going to play the role of two people in this video with the same voice, obviously. And I'm going to take these pencils and I'm going to, on my white piece of paper here, I'm going to construct a triangle just given the three lengths, and do the best you can. We're not robots, so this isn't going to be perfect, but you want to try to get the full length of each pencil or pen or whatever you're using to construct this triangle. And once you've constructed the triangle, what you want to do is you want to mark each vertex approximately where your writing implements meet. Now once you've done that, you want to move your three writing implements, construct some segments by connecting the points. And voila, we have a triangle. This would be when it's a good time to get your Sharpie marker and maybe embolden this triangle. Try to trace right on top of those segments. All right, we have a nice bold triangle, easily seen. And now, if we were in class right now, what we would do is I would ask you to go to your partner now who's been watching you and pass the implements over, the same implement. So again, the three writing implements we decided to use, your partner must also use the same exact ones. Now your partner was watching you, but even myself now, after creating this triangle, I've already forgotten how I arranged those parts. But what you need to do, this is a must, is you must make sure that when you are producing a second triangle now, that you are using the full length of the writing implements. Do not, under any circumstances, shorten a length by doing this, because that defeats the purpose of the activity. We want to use the full length we're given for each of these three writing implements to produce another triangle. Okay, so we have two triangles now. What information were we given about our two triangles prior to construction? Well, that information, even though it wasn't, a statement or anything like that, was that we were given three writing implements to create and produce a triangle. What do these three writing implements represent about the triangle? These three writing implements, since they were used by both partners, represented the side lengths for our triangle. And that's all we were given. Note, we were not given any information about how to open up any angles. We were just told to take our same three side lengths, connect them at their ends, and produce our triangles. The two triangles should relatively close overlap. Now, we are human beings, so we're not robots, so they're not going to be perfect. We're not machines. But these two triangles we've created should be close enough to overlapping. They do appear to be close to the same without having the ability to overlap them. So what does this mean then? We've taken our three congruent segments that each partner had, and we produced two triangles. And those two triangles are basically congruent to each other. Well, if all we needed was three congruent lengths, our pencils, they're the same for both partners, so that we would say that these are three congruent lengths. These two triangles have three congruent sides that correspond. If two triangles have three congruent lengths that correspond, then they must in fact be congruent. We don't need to know anything about the angles. The side-side-side congruence postulate says that two triangles are congruent if all three corresponding segments are congruent to each other. If I knew a pair of triangles had three congruent segments, I don't need to use the definition of congruent polygons and then worry about their angles. The three congruent segment lengths was enough to prove congruence.